Students, we're going to go over electron configuration. So I want you to get out this page in your packet. I think it's page 8. And we are going to talk about how to write electron configurations. I'll just move me down here. Okay, so with electron configurations, first off, when we were talking about drawing the Bohr model, we were talking about how that's not an accurate representation of what the electrons are doing, of where the electrons are in relation to the nucleus. They don't actually travel in a circular path around the nucleus. Now, there are energy levels, and when you look at this periodic table here, our energy levels are going to be over here, represented by the rows on the periodic table. So all of these represent energy levels. So right now there are 7 energy levels around the nucleus. Now that gives us a rough idea of where the electron is located. So it's like if somebody asks you where you live and you say, well, I live in Kingwood, well, that gives us a rough idea of where you live, but it doesn't give us a very specific location. Electron configurations give us a more specific location of where to find these electrons. So you can see that on the periodic table, I have these numbers and letters labeled in these different spots on the periodic table. So as you can see, the periodic table is divided into 4 blocks, S, D, P, and F. These blocks represent sublevels. So within each energy level, there's different sublevels where the electrons are. So when you look at, for example, 1s, the 1 represents our energy level, and the S represents the sublevel. And that's just giving us a little bit better idea of where the electrons are located. So instead of just saying that the electron's in the 3rd energy level, you could say it's in 3D sublevel. Just like when you're talking about your address, you could say that you live in Kingwood, or you could say that you live on Golden Pond, which is a street, and it gives you a more specific idea of where the electrons or where you live. Okay? Now, when we write electron configurations, we read the periodic table like it's a book. We move left to right, top to bottom. So you're always going to start writing your electron configurations with the 1s. So with hydrogen, for example, you would start with 1s, and it's in the first block because it's right here. So it's going to be 1s1. That 1, going back down here to our little chart here, that 1 represents the number of electrons in that particular sublevel. So hydrogen only has 1 electron in that sublevel, so it's going to be 1s1. So when we look at helium, which is over here, helium's electron configuration, we start over here, top left every time. It's going to be 1s, but helium is in 1 second column, so it's going to be 1s2. Okay? Now we keep adding on different sublevels to represent where all of the electrons are located. So every neutral atom is going to have a different electron configuration. So when we look at lithium, lithium is right here, for example. When we do lithium, we always start up here with the 1s. That's always the first thing that we do. So it's going to be 1s. We have to get to the end of that row, 2, before we can move on to the next row. So then it's going to be 2s1. Because these superscripts represent the number of electrons, you can see that when I add these together, I get 3, which is the atomic number of lithium. So you can always check your subscripts, add them together to make sure that you have accounted for all of the electrons for that particular atom. So let's skip a couple and let's look at carbon, which is over here. Carbon, we always start up here in the top left. So the first thing we write is 1s2. We can never have more than 2 in the s sublevel because s sublevel can only hold 2 electrons. So we have 1s2 to get us to the end of the row. Then we have 2s2 to get us to the end of that sublevel. And then we're going to have 2p, and carbon is the second column, so we have 1, 2, 2p, 2. Adding up all of our superscripts, 2 plus 2 plus 2 is 6 electrons, which is the same amount of electrons that carbon has. Let's skip a couple more and we'll do chlorine. Down here, so chlorine, again, where are we going to start with our electron configuration? We're always going to start up here in the top left. So we have 1s, 2 to get to the end of that sublevel. Then we have 2s, 2 to get to the end of that sublevel. Then we're going to have 2p to get to the end of this one, that's 6. 1, 2, 3, 4, 5, 6. So 2p6, that gets us to where neon is. Then we have 3s2 to finish out that sublevel. And then we have 3p, 1, 2, 3, 4, 5, 3p5. And that's the electron configuration for chlorine. Now, we talked about valence electrons when we were drawing our Bohr models. You don't have to draw the Bohr models to see how many valence electrons there are. You can look at the electron configuration. So remember what I said was these first numbers represent the energy levels. And valence electrons are in the outermost energy level. So here, our furthest out energy level is going to be energy level 3. And you can see that we have 2 plus 5 electrons in the third energy level. So chlorine is going to have 7 valence electrons. Okay? Now let's do something that's a little bit more complicated. Let's look down here at tin, which is all the way down here. So when you write something like tin, you always start up here in the top left. So we have 1s2. And then our next thing is 2s2 to get us right here at beryllium. Then we have 2p6 to get us where neon is. Then we have 3s2 gets us to magnesium. 3p6 where argon is. Then we have 4s2, which is where calcium is. Now here's where things get a little tricky. Your D sublevels. Notice that the number is 1 less than the row or the energy level where that atom is found. The D sublevel actually has more energy than the S and the P. So we are going to fill the third energy level after we put 2 electrons in the fourth energy level. So that's why with calcium, we only had those 2 valence electrons, because these ones in the yellow go back and fill up the third energy level. Okay, so we have 4s2, then we have 3d10, because there's 10 electrons that can fit into the D sublevel. Then we have 4p6 to get us to the end of the p's. 5s2 is going to be next. And then after that, we have 4d10 to get us to the end of the d's. And then we have 5p2. And that gets us to the end of 10. Okay? Now there is a shortcut. Let me change my color here. The shortcut is called the noble gas configuration. So your noble gases are over here in the last column. We have helium, neon, argon, krypton, xenon, and radon. So those are your noble gases. So a noble gas configuration puts a noble gas in brackets, therefore accounting for the electron configuration of that noble gas. So if we look at tin again, which was right here, when you write your noble gas configuration, you look 1 row up and all the way to the right. That noble gas goes in brackets. So with tin, we're going to put krypton in brackets, and that takes into account the electron configuration from hydrogen to krypton. So since tin is in the 5th row, we pick up our electron configuration at 5s2, and then 4d10, and then 5p2. Okay, so let's look at a different example. Let's say we have, let's do something for fun, gold, right down here. Gold, if we look 1 row up and all the way to the right, xenon is going to go in brackets. That takes care of the electron configuration up through xenon. Gold is in row 6, so we're going to start writing our electron configuration at 6s2. Then you'll notice that the F's fit right into here on your periodic table. So after 6s2 comes 4f14, and then 5d10, and then, sorry, not 10. Gold is right here, so it's going to be 5d9. Okay? So if you have any questions about writing electron configurations or noble gas configurations, please let me know, and then go ahead and watch the orbital diagrams.